Hello, my name is Daniel Blake. I am just doing the first three questions of the project. So the first one is the sample proportion question. So here, x, I'm just doing like plugging in my values. So x is 56, which is the honor graduate students. N is 152, which is the, the total students surveyed. And then we divide it, we need to use P equals X over N, and then that's, you just plug that in, P equals 56 over 152, which is approximately 0.3684. And then from there, we can do just a standard error, which is, right here you can see SE equals, P times 1 minus P over N, and then you square all of that, right? So you do that, plug in your values. You can see I did SE equals 0.3604 times 1 minus 0.3684. And then you divide that over 152 to get approximately 0.0391. And then you do the margin of error, which is, you're multiplying z by the standard error. So it'd be 1.96 times 0.0391, which is 0.076. Right. Okay, or well, you can do 77, I guess, around it. And then we're doing the lower bound, which is we're getting the actual interval the question asks for, which is essentially P minus margin of error, which is 0.3684 minus 0.0766, which equals 2.818. Okay, and then we have the upper bound, which is just the same thing, where it's just P plus 0.3684, which is 0.3684, adding 0.0766, which just equals 0.4450. So then I write the interval there. You can see it right here. It's just lower number first, because that's what it asks for, with just those two values. And that's the end of the question. Okay, so now number 2. This question, 1 second. Just pulling it up so I can read the actual question. It's just asking the researchers were trying to find the relationship between the number of employees and the average number of work-related injuries. It gives us the data, and we have to compute the correlation coefficient. So that's pretty much just solving for R. I have the equation written down here, which has the sigma notation, and then x minus x, y1 minus y, and et cetera, et cetera. So or I rather, not one. But yeah. So from here, you're just you can calculate the mean first, so the mean of x, which is just adding all of the data we have from the table that's on the question. So I add 19 plus 26 plus 30 plus 31 plus 34 over 5, which equals 140 divided by 5, which is 28. So that's the mean of x. And then the mean of the y value is 11 plus 8 plus 6 plus 6 plus 5 divided by 5, which is 36 divided by 5 equals 7.2. So we have our data from there. And from there, we're getting the individual deviations, or standard deviations, which I multiply. And then essentially, it's just plugging it all into the huge correlation coefficient equation, which you can see I do here. And then eventually, I won't go over it because it's kind of long, but you can see I'm pointing it. You go down and down and down, and then eventually, right here, you can see R equals negative 55 over 134 times 22.8 squared, and that will get us the correlation coefficient of negative 0.996. And that's just part A. So from part B, it's a lot more simple. We're just plugging in the equations pretty much. So here we're trying to find the regression line, which is y equals ax plus b. And then b we can find by just plugging in our values of, so here you can see I do b equals negative 55 over 134, which gets me approximately 404 or 0.404 or 4104. Oh my gosh, I can't speak. And then from there, you plug that in into this equation to get A, which is A equals 7.2 minus 0.41 or 4104 times 28, which equals 18.697. Oh, I'm showing this badly, but you can see it right here. Just to be more clear about everything, it's this part from part B right below this equation. You can see it all here going on. And whatchamacallit, from there, you get the equation of y equals ax plus 18.697, which I write down right here. And then from there, it gives us the value of 32 that we just have to plug into the equation. So it is y equals, so you see the equation we have right here just written down. Y equals 0.4104, and instead of x, we're replacing the x with 32, so it's 0.4104, negative 0.4104 times 32 plus 18.967, or 697 rather, and then from there, you do that, and then you get the value of 5.5642, and that's the end of the question. Okay, well, that's not the end. I almost ended the video. That's not the end of the video. The third one, it's another, it's a null hypothesis question. And from here, we can see the null hypothesis is, whatchamacallit, what am I trying to say? Right, it's proportionate to the data. That's what we're trying to, what the question's asking here. And same thing with the, alternative, the proportions are a little different for the alternative hypothesis, so it's whatchamacallit, so these are like slightly different because they always have different things, but then it asks us what equation we need to do, so we devise that we need to do equals n times p, and n is just the sample size. You can see right here, I read it, n equals 200, and then p is the proportion, and then we have odd proportions like the data, which is 29%, which we can then go down to like 0.29 and then 0.38 and then 0.39. Those are the percentages from our sample data of the new medication, old medication, and no preference. So whatchamacallit, so there you can see I'm writing down all the values before we start plugging in the equations right here. So it is like E1 equals 200, E2 equals, or 200 times 0.29 equals 58, E2 equals 200 times 0.38 equals 76, E3 equals 200 times 0.39, which is 78, and then we're essentially plugging it into the chi-square test, which is this old equation right here, that we're plugging it into, and we're doing that for each individual one, which is, this includes the new notation O, so O1 is 69, which is the other data, by the way, from the new medication, old medication, and no preference. So O1 is 69, O2 is 44, O3 is 87, and then you're mixing that with the E values that we just solved on the other ones. So then you plug it into the equation, and you do that 3 times. You do the equation 3 times because you're plugging it into each one. So you do 69 minus 58, because the equation is the segment notation, O minus E divided by E, and square, or yeah, whatchamacallit, to the power of 2. So whatchamacallit, here you can see 69 minus 58 squared divided by 58, and then we get approximately 2.085 from here. You can see right here, if I'm showing that good, yeah, there. And then we're plugging that in. We're doing the same thing for the other numbers. So 44 minus 76 squared over 76, which will eventually get us 13.47. We have 87 minus 78 squared over 78, which will eventually get us 1.04. And from there, we can do x squared, which we just add all of them together, where we do 2.083 plus 13.47 plus 1.04 equals 16. I can't read. 16.593. And then seeing as the, whatchamacallit, with the significance as being 0.10, we get a critical value of around 4.605, which is essentially proves that we are rejecting the null hypothesis. But yeah, that's pretty much those 3 questions. Thank you so much.